Okay, let's get this kicked off. Thanks for coming, everyone. Today we're going to look at lessons learned from billions of security reports. My name's Scott Helme. My Twitter handle's up there. I'm actually really close to 20,000 followers. If you could help me out, it's how I judge myself as a person, by how many Twitter followers I have. And I'm here today to talk about a little project that I started a long time ago, actually. Some of you, if you've seen me on Twitter, read my blogs, you will have heard of Report URI. Now, it's not a sales pitch, and hopefully as we go through, you'll see I've made every effort to make this not a sales pitch. What I want to do is kind of tell you the story of how this project came to be. So it was a tiny little project that I started years and years and years ago, and now it's a fairly big company that processes quite literally billions of security reports every month. So there's a couple of personal stories in there, the technical story of how we actually scaled from a hobby project to 16,000, 17,000 reports a second we get at our busy peaks now. So this is us, if you want to check us out. ReportURI.com. We are a security reporting service. I'm going to talk a little bit about the kind of reports that we get and how, and also how we handle them at scale, because that's really the big thing here. This has grown to be kind of so much bigger than I ever expected it to be. So the kind of reports that we get, we support native reporting mechanisms in the browser. So pretty much every mainstream browser now has one or more of these reporting facilities built in. We typically think of the browser as hey, we'll just render a page, send it to the browser, it will show it to the user, and it's just like a portal at the other side that we throw stuff at. With the browser now, you can actually ask it to become an active participant in the delivery of the browsing experience. So all mainstream browsers support this, and what you can do is you send your page to the browser and say, here is my page, please show it to the user, but if something goes wrong, please would you tell me? And we have these automatic reporting functions built in. So I'll give you a specific example of one of them. The first one is called content security policy. So what we do with content security policy, as you can guess from the name, it is a security-focused policy. Like I said, these are largely security mechanisms for now, is you deliver something called a content security policy with your page. So we can see HTTP response headers here that you would see on any normal web page, and we've added an extra one called content security policy. Now, the idea of this is that you give the browser a policy to enforce on the page, and that policy, if we expand it out, might look something like this. So we've given the browser this CSP, and what we do with CSP is we control where content on our website is allowed to be loaded from. So we're saying, OK, by default here, the default source is self, which means by default I can load things from my own domain. But then we get more specific. Script source, I'm saying here on my website, I load script from myself, and I load script from this CDN. And what this means is if the browser is going through my page and rendering it and sees a script tag from evil.com, the browser will look at that and say, right, script tag, source attribute, evil.com, it's not in the whitelist. It's not allowed. I'll throw the script away. So you've now been able to control exactly what script loads on your website. And this is a super powerful feature in CSP. Same again, everything else is fairly self-explanatory. Style source, image source, where can we load those types of content from? Form action's a really good one. Where are forms allowed to post to? So it's not just where can I load stuff from, it's also where can I send stuff to? And we also have things like the connect source, where you can control XHRs. So with CSP, you can really start to take a lot of control over your page. And then the kind of last line here, the really important one, is the report URI directive. And what we do in here is you specify an endpoint where you say to the browser, if something happens that is not in accordance with this policy, would you please tell me about it? Would you send me a report? So let's say it found that script tag with the source attribute of evil.com. Great, the browser's blocked it, but you don't know. And this is where the reporting comes in. You say, please block the bad thing, but also could you tell me that a bad thing has happened? So this is what the script tag would look like. I'm pretty sure that we can all agree. OK, raise your hands. Who wants this script tag to load in their page? Right? OK, nobody wants this to load, and the browser will now block it, which is fantastic. But the reporting is like the final piece in the puzzle, because if the browser blocks it and doesn't tell you, when are you going to fix this? Right? It's just going to stay there forever. So with the reporting enabled, the browser will dispatch a HTTP post request with a JSON payload. And the JSON payload contains all of the information that you need to know about what went wrong. So first line, document URI. What page was the user visiting on your website when this happened? Next one, violated directive. Well, it was a script tag, so it violated the script source. It gives you the original policy, so you can see what the browser was working with in case you have different policies on different parts of your website, maybe different countries, wherever. And then the thing that it blocked. So I could receive this piece of JSON and go, right, so someone came to my home page, And there is literally a file on there trying to load keylogger.js from evil.com. And the browser's blocked it and told me about it. Now I can go look how that got there. Remove it, fix it, maybe we've got some kind of security issue. Whatever happened, it doesn't matter. The point is that you get the report so that you can know that the thing has happened. So that's a really quick overview of CSP. You can use this to do so many more things as well. It's not kind of a talk about CSP. What I wanted to show was how the browser actually sends these reports, because these are the kinds of reports that we collect. You ask the browser to send these JSON payloads to us. And it's not just for CSP either. There are several of these mechanisms built into all mainstream browsers. We have quite a few different ones at our disposal. So take a look through them. We've got CSP up in the top left here. That's the one that I just talked about. HBKP, this is slightly controversial right now because it's such a powerful mechanism. And if you deploy it and get it wrong, you can literally break your whole website, like actually break your website and turn it off. So Chromium is currently talking about deprecating this. It might not be around for much longer. Certificate transparency is another really good one. If you've not heard of CT, just Google it and have a look. It's a really cool mechanism where you can search through all certificates in existence, and the idea is that you look for certificates issued to your website. The XSS auditor. Who knows that most mainstream browsers have an XSS auditor built in? Does anyone know? Anyone seen those? So the attack that I talked about a minute ago with the evil.com script in there is what we might refer to as a cross-site scripting attack. Some bad JavaScript gets into your page via whatever mechanism, and generally it's going to give your user a really bad day. Most browsers now have an auditor already built in that's trying to detect attacks just like that. And if it sees one, especially in Chrome, Chrome's really kind of strict with this, they will stop the script from running. It will identify it and say, this script looks hostile. I think I'm just going to take that out and stop it from running. Now, Chrome already does this, and it does this by default. So this could already be happening on your website. With the reporting mechanism, what you can do is ask the auditor, if you step in to save my user from what you think is an attack, please would you call home and tell me? Now, it's already stepping in and saving your users from attacks. You just don't know it. And this is kind of the thing that blew my mind a little bit, is like, there's already stuff happening on my website that I don't know about. We really should be gathering this feedback from the browser. And then the last one, OCSP expect staple. This is a really kind of in-depth mechanism about certificate revocation. I've actually done a talk online in collaboration with an NDC event, so you should check that one out. But they're all security mechanisms. They're all based around the client side, where the browser can become an active participant in kind of the security of your site, really. So these are all of the different types of reports we collect. The browser will come to your website. Let's say, a good example because we were just talking about PayPal earlier. Let's say PayPal was one of our customers. You go to PayPal's website, there's some kind of error. The browser would dispatch that report to our service. We process it. We generate dashboards, graphs, things like that. So we need the infrastructure on our side to be able to take these reports. If you're a high-traffic customer and you get lots of errors on your website, all of your visitors, if you've got millions and millions of visitors, will send us millions and millions of errors. Now, that wasn't the case when we first started out. When the first month that I built the service, there was literally just me using it because it was a side project. I'd seen that the browser was capable of sending these reports, and I thought, this is awesome. I can get all this feedback. I Googled around for like 5 or 10 minutes to find a service that I could subscribe to, and there wasn't one. So that's why I built it. So our infrastructure, when I first built it, was really simple because it was literally just me, and I didn't anticipate that anyone would actually use this. So for sins in a prior life, I'm a PHP developer, and most of our application is hosted in DigitalOcean. And we're just on like plain old Ubuntu servers running PHP 7.2 and the current version of mainline Nginx. Now that's really good. The processing code is kind of simple. We're just taking JSON payloads, processing them, and then we need to put them in some kind of database. And I'm not a database person. Are there any database people here? You're like a special breed of people. I've never been able to do databases, and I was like, look, I need some kind of managed service for this because I'm not a DBA, and I can't become one on top of everything else. So I actually turned to Azure, and in Azure, I use specifically one of their services called table storage. And table storage is just a super simple key value JSON store. So you put something in with a key, and then you can retrieve it later on with that key. And sometimes people say this is a bit odd because we've got like our application running in DigitalOcean and the database in Azure, but they just worked so well together for us. And from the cost standpoint, the other thing people ask me is if I've looked at, I think it's DynamoDB in AWS. We did some extensive testing with that, but it was way too expensive for our particular use case because of how they bill. So we settled on DigitalOcean and Azure. And the interesting thing is this is still our infrastructure today. We are still hosting using exactly this setup. So it has worked, it did work, and it scaled really well. So first month, we processed just over 10,000 reports, and that was literally just from my own personal website that came in. And then things started to grow. A couple of friends used it, a couple of people heard about it on Twitter. It started to grow and grow and grow. And you think, great, right, well, you built this thing in the cloud. If you're hosting an application in the cloud and you need more resources, you just add more cloud and just dial up the numbers. And this is kind of the point in cloud infrastructure, right? So you just take the dial and you can twist it all the way up to 11. And for the first many, many months, this is what I did. Every time more people started using it, get more reports, and it actually just auto-scaled upwards. And the only problem is that on the other side of this dial is also the cost dial, and they're fixed together. So as you start just cranking up the dial for the amount of cloud, you also crank up the cost. Double the amount of compute resources, double the cost, which was great when it was literally costing, I don't know, like my first month was single-digit dollars. I didn't even care. But if you keep dialing that up and up and up, it becomes unmanageable. And from when we launched until where we were about 3 months ago when I first started working on this talk, we've actually done times 2 million on our monthly load. So even if I was only spending $1 a month, and that very first month, we would now be spending $2 million a month. And this was just not scalable, and it became unmaintainable a very long time ago, and we had to get smarter about how we were using those resources and how we process things. So the following is kind of like the basic story on how we've adapted our service to go from 10,000 reports a month to well over actually about 16,000 a second at our peak now. So basic infrastructure diagram. Again, on the right-hand side, those are the browsers. Maybe they've just navigated to PayPal's website, had some kind of error, and they would dispatch a report over to our ingestion servers. These servers reside in DigitalOcean. We do things like schema validation on the JSON, so we want to make sure that they're not junk reports. We do some basic filtering and spam detection on them. But ultimately, if we decide that, yes, this is a valid report for this user, we need to insert it into Azure, into that user's table. Now, because of the way our application servers are completely ephemeral, they have no state, and also because of the way that Azure works, the first thing that we have to do when the report hits us is even see if this user exists. So the report comes in, and the application server is like, I don't know. So it'll reach into the database and pull back the user's entity. Now, this would contain things like their custom filter settings as well, because each user can tweak what kind of reports they accept and reject. It would look through those, do all of its filtering, and then if it needed to put it in the database, we actually store 4 copies of it, which sounds kind of weird at first, to actually denormalize data on the way in like this, but we store the reports in 4 different time slices, and they are the hour, the day, the week, and the month. So we'd have to put 4 copies of the report in, and I'll explain why, because this really improves our query performance later. So we put these 4 copies of the report in, but table storage is a really basic key value store. There is no like increment operator, so we can't just increment the count on an entity. You actually have to query the entity out, increment the count, and then put it back. So we've got the 1 query to get the user entity, 4 queries to pull the 4 rows out, increment them all, and then put the 4 back. So we actually had, for every inbound report, we were doing 9 what they call transactions against table storage, which was fine at the beginning when we're doing 10,000 reports a month. It's like, okay, multiply by 9, 90,000, we can tolerate this. And the reason that we could tolerate this for a very long time was that pricing model in Azure. And we had this fantastic thing where 10,000 transactions against table storage was like 3 1/10,000th of a dollar. It's really, really cheap. So even if we get into like the millions and millions of transactions against table storage, it really didn't matter that much. And that kind of drove the design in a way, because it's like, okay, well, this is quite transaction heavy. Well, transactions don't cost a lot, so we don't really care. So this was how we first started out. But the problem was, as the service grew, even though that number is really, really small, when you start getting into the millions, tens of millions, and hundreds of millions, it starts becoming not small. And we're also paying for things like the bandwidth, ingress and egress from Azure as well. So we had to start getting a bit more kind of sensible with this. We had to start becoming a bit more frugal with our use of the cloud. And one of the first things that we did was try to give our application servers some kind of state at the edge. Because as I said in the diagram a moment ago, they have no state. They were literally just operating against the database directly. So we manage our entire fleet with Ansible, which made this really easy. Changed the config. We deployed a memcached instance onto every one of our edge nodes. The sole purpose here was to cache that user entity on the edge node. So when the first inbound report comes in, and the application server had to reach back and grab the user entity to see if they existed, number one, what their filter settings were, things like that. Now it could cache that user entity on the edge node. From memory, this was a long time ago. I think we cached that for about 10 minutes in memcached. So if you did change your filter settings, it would only take a maximum of 10 minutes to update across our entire infrastructure. And this was really good because it was a super simple change, drop memcached on there, and then use that as a buffer between the application server and table storage. So it allowed us to chop down one of those transactions against table storage for each inbound report, because now there's only the 4 time slices out, increment, put the 4 back. Now, around about this time, we were starting to get some really significant load. We were definitely getting into like the tens of millions per month. And unfortunately, something happened that really expedited our interest in being able to handle this kind of load. We don't really talk about it much because it's not one of my most favorite memories, but we got hit with a massive, massive traffic flood. Now, we call it the DDoS. Most people are probably familiar with the distributed denial of service attack. Normally, it's just when horrible people on the internet flood you with just like waves of traffic that you simply cannot tolerate as a service. They're normally hostile and they're normally designed to knock you offline. The only difference with ours is that someone did this by accident, but they did still knock us offline. So I wrote a blog post about what happened here, and the company was actually really good about this. They let us use their name and really give the full story of exactly what happened, but someone configured one of these policies on their website. And they're a really, really big website. At the time, they were one of the top 100 websites in the world, but they misconfigured their policy on their website very, very slightly. And what it meant was that every visitor to their website sent us about 64 reports. So that's 64 individual JSON post requests, like one behind the other, when they landed on this customer's website. It was Envato, was the company. They run websites like Theme Forest, Audio Jungle. Some of you may have heard of them. So one visitor lands on their web page, and then that visitor would literally fire like 64 sequential post requests against us with a huge JSON payload. And then they go to the next page and fire another 64, and the next and the next. And when they get millions of customers, we were literally getting hundreds of millions of these JSON payloads coming in. So the problem with that is 1 second they're fine, nothing is wrong. They deploy the misconfiguration, and then the next second it's like fire hose. We went from literally nothing to unmanageable amounts of data in literally a couple of seconds. Now, back then, I was using New Relic. You may recognize the dashboard. We've since changed, but the numbers are what we're interested in here. We had our 2 load balancers at the front, and they spiked well off the top end of their capabilities, so the application started to scale, deployed the 3rd load balancer. This one's up and online, hasn't propagated in DNS yet, but we're already at like 8,000 and 9,000 requests a second. The problem was, by the time that one had propagated in DNS and started receiving requests, we were already well off the top end of their capabilities again. Same thing happened, it added the 4th load balancer. This one's kind of just started to propagate in DNS. We're into like literally multiple tens of thousands of requests a second. And again, these aren't just like GET requests. These are actual post requests with a JSON payload that we have to do a lot of stuff with as well. So it becomes really hard to deal with this. I was getting hundreds of emails a second from basically our entire fleet was on fire, and I was getting all of the alerts. And it's like, what do we do? Do we just let this keep scaling and try and tolerate this, right? Like, there's a point at which you can scale far enough that you can handle this. The problem was the time allowance that we have for the next scale wasn't good enough, and the traffic was essentially getting away from us. And whilst I was thinking about all this and what to do with it, we were kind of hitting out the peak here. And I'd stopped it scaling at this point because I'd noticed the traffic was getting away from us. There was no way that we were going to scale far enough. And this is still like a personal side project that I'm paying for as well. I have to admit that had something to do with it. And it's just like, yeah, we're just adding these. And every time we add them, you know, we're doing like 40, 50,000 requests a second on each of these load balancers now. In terms of traffic volume, even our New Relic monitoring suffered. Like, we couldn't maintain full monitoring, but we were seeing kind of like 0.5 gigabit a second of JSON coming into our load balancers. So all in all, it was about 2.4 gigabits a second of JSON, which is just way too much for us to cope with. And it's like, what do? Well, we can't scale to cope with this. Maybe we can get in touch with the customer and ask them and say, hey, please can you turn this off because you're literally fire hosing us and we can't do anything about it. Now, the good thing I say good thing, it's probably not a good thing. The good thing is that we didn't have to make that decision or call them. The bad thing was, it's because our hosting provider got in touch with us and said that they were dropping us because we were getting way too much traffic and impacting their service. So DigitalOcean sent me an email to say, your IP addresses are receiving just really abusive levels of traffic. They're negatively impacting our infrastructure, so we're just going to stop routing traffic to them. And I was just like, oh no. They're so mad, they're going to be really cross. If your hosting company emails you to say, like, we're basically killing the traffic to your infrastructure because it's too high, I thought that this wasn't going to go really well afterwards, and I kind of expected them to be a bit mad. But they were really good with this. They worked with us. They tried to help us out in any way that they could, but ultimately they said, look, this is negatively impacting other customers within our environments now, so we need to stop your traffic until the inbound stops. I was like, right, okay, well, that solves our problem. Now we're completely offline because our servers have literally been pulled down. But how do we stop the traffic coming in? Like, if you have too much traffic that's hitting you, there's no simple kill switch for that. And this was a really big problem because I'm trying to fight through, like, the one email address that registered the account, trying to get a hold of that person. But it's completely the wrong time of day, and they're not going to be awake for another 9 hours in America. So what do we do? And this really highlighted the problem for us, that if someone actually did this again, we would find ourselves in exactly the same situation again. And the problem really was a mistake that I'd made early on in the project. Now, you may have noticed in the address earlier before, when you want to send us a report, you send it to reporturi.com/report, and then this value here we call your report token. It's just a vanity string that you can pick when you create an account. And that's how we know any report sent to this endpoint got into my account, because that's my report token. So you can sign up, you can pick whichever one you want, and that's how they're routed. The problem with this is, when a browser comes to resolve the domain to send the report, they're all actually sat on the same host name. All of this is sat on reporturi.com, which means they all resolve to the same IP, and the load balancers that handle our application traffic for, like, the www, for the homepage, for tools, login, account, the same load balancers also have to handle the inbound report traffic. And this meant that when we were getting the flood of reports, our website went down with it, because all of these servers are taken out, everything that runs underneath them is also gone. And I was like, well, this is really bad, because our website was literally unavailable throughout this whole process anyway. And that's when I had, like, a real light bulb moment. I need to kill this traffic. I need to stop it. And the problem is, if you want to try and filter /report/ScottHelme, you're already doing that on your application servers, and that's already too late because the traffic's already hit us and it's already done the damage. Now, can anyone see what my really silly mistake was? What's the solution to this?
The answer earlier on your CSP slide.
Was it okay? So someone was paying a lot of attention. Take the report token and push it into a subdomain. And this is literally all that we had to do to solve this problem. So now those report tokens, like mine, is on scotthelme.reporturi.com/report. instead of having the Scott Helme on the end. And what this means is two really big things for us. Number one, we could have a set of IP addresses for our web application with its own dedicated and segregated infrastructure. We can then resolve a wildcard for all of our customers. It doesn't matter what, like, vanity token, vanity subdomain you picked, it will be picked up by our wildcard DNS entry. And what this means is that if one particular customer started to become really abusive and really hostile, like Troy, we can resolve his IP and kill him at DNS. And what this means now is that this report doesn't even get sent. We don't have to take this onto our load balancers, try and kill it at layer 7. We can literally stop the browsers out in the world from resolving to us and stop the traffic even being sent over the network. And this was a huge kind of obvious thing for me after we'd been through the terrible experience of essentially being DDoS. But give yourself this flexibility. In scenarios like this, I'd not thought of this, and it was a really obvious big win. The other cool stuff now, since we did this, I largely did this for traffic control, because we do still use this mechanism if we have really abusive customers that go through a bad spell, or someone's just DDoSing a subdomain. There's loads of people on the internet that like to do stuff like that. We can just kill it at DNS and say, look, this is just a flood of traffic that we don't want. Just turn off that subdomain, and it will stop hitting us. The interesting thing since, we've then repurposed this, the exact same mechanism, because we now have customers that need European hosting and processing because of regulations in Europe, which is really good because we can just put a specific entry in from them and then route that to our European infrastructure. So we now have another data center alongside the one in San Francisco in Amsterdam. So we can resolve just their particular subdomain to the one in Amsterdam, which means that any traffic they have will just naturally flow to our data center in Amsterdam. So now we're doing like geosensitive resolution for them as well. So you can give yourself a lot of flexibility, and this wasn't a costly thing to do. And in terms of the code changes, it was minor, because now we just look for the token in the subdomain instead of the path. But it gave us so much power, so much flexibility, and so much control from such a minor thing. And I wish that I'd seen this a lot earlier before I went through all the stress of the DDoS. So we still had exactly the same infrastructure, but during this, one of the other things that I decided to do as well was those 4 time slices, we dropped them down to 3, because the vast majority of people in our UI, when they were querying to see their reports, they were using the hour, the day, and the month. The week time slice it didn't seem to be something that people really used, and for the amount of use that it got, it wasn't worth the extra traffic against Azure that it was costing us. So we got rid of the week time slice. We now just have hour, day, and month. And that got us down to a 1:6 ratio on reports to transactions, which isn't very far. We've come from 9 down to 6. It's a step in the right direction, and as the service is scaling, this isn't actually making it cheaper. What it's doing is just reducing the increase in cost. But I was still really struggling at this point, because this was a free project. This was something that I stood up just so that people could have it and use it. And we needed to change that. We needed to get the cost right down, because otherwise, this was blowing my side project budget of $100 a month. My wife was getting really mad, and why are all these big server bills coming in every month? So I fixed this with Redis, and this was a more recent thing. We made this change earlier this year, and what we tried to do with Redis was we could get rid of memcached on all of our edge nodes now, because we didn't have an individual cache per server. We had one central Redis cache in our infrastructure. And this is actually, I really like this. It's massive, powerful server. It's got loads of RAM. And what it was acting as was basically a buffer. So when the ingestion servers come in and take the report, they now do the same basic filtering. We do spam detection. We throw away junk reports. But rather than the ingestion server interacting with Azure and incrementing the count, it just places it into Redis. So Redis does have an increment operation as well, which is great, because it can just increment counts against Redis. And the Redis cache runs in just like a circular buffer. So we just fill that up, and sat behind it, we have what we call our consumer. So the consumer will come along every 10 seconds and take the whole content of the Redis cache, and it will then process those reports into table storage. So what this means is that, number one, the ingestion servers now have much less load, because they're not opening and firing multiple transactions at Azure, so it reduced the overheads there. Because we can stack with a count in Redis, in that 10-second window, if we get 8,000 of the same report, we just have a single copy of it in Redis with a count of 8,000. And then the consumer only has to do the single transaction against Azure with an increment of 8,000 instead. Now, apart from the actual cost of the Redis server, the only thing that really changed was it added a 10-second delay for reports to show up in your dashboard, because the Redis cache will sit on something for potentially up to 10 seconds after it lands. And as much as I don't like that, I didn't want to add that artificial delay. For the benefits that that brought to the service, that was just a no-brainer. 10-second delay we can pretty much live with, to then be able to flatten, in some cases, tens of thousands of reports into a single report, because we normalize the JSON here as well. Different browsers have a tendency of not following the specification exactly, and they have slight nuances with their JSON payloads. So we normalize those as well. And this made a huge, huge, huge difference in our infrastructure, because whilst the Redis cache is expensive, the number of transactions that we did against Azure after we introduced this plummeted. And we were now doing an average of 0.01 transactions against Azure for every single inbound report, because of the deduplication and stacking them on the way in. Now, around about this time, we were almost becoming a commercial service. We became a commercial service last year on November the 1st. And for the 3 years prior to that, I had run it as a free service. So anyone could come, anyone could sign up, anyone could use it. And despite all of these changes that I'd made and all of the progress that I'd done, it got to the point where it was just costing too much money. And I don't know, maybe some people here have, like me, little side projects. I just like building stuff and writing little code projects and things. And this one just happened to take off without me having expected it. And it got to the point where it was like, well, what do I do? I can either close this thing down, because it's costing me hundreds of dollars a month now to run this, or I can commercialize it and ask people to start paying for it. And I hate it when services do this. It's like, hey, join our free subscription thing. And then 2 years later, it's like, now you have to pay. And I didn't want to be that guy. But the alternative was to literally close the service. So I didn't want to do that. I wanted to keep it running because I felt it was genuinely useful. So we commercialized. We still have a really good free tier because I wanted to carry on doing what it started out to do, which is to help people deploy these mechanisms. But we now do have, for very large users, a paid tier that you have to go on to. But even then, the free tier is very generous. The paid tiers, if you have a look at our pricing model, we can process millions of reports a month for you for like tens of dollars. And to do that, we needed to continue to drive this efficiency. And we made a change recently, which is the start of many that we're making this year, where we had to both literally and figuratively push this to the edge. Number one, in terms of what we could squeeze out of our resources, we had to absolutely max out what we were getting from them. But number two, the other thing was we quite literally moved some of our code from our own application servers onto our edge nodes, because at this point, a CDN provider had stepped in and decided to offer us some help. So Report URI, our service, now sits behind Cloudflare, who are a CDN provider. Now, in the traditional sense of a CDN provider, they sit between the browser and our servers. Now, many people are familiar with CDNs. They cache files, like static parts of your website, maybe even whole pages, depending on whether or not you have dynamic content. And this is kind of like the more traditional role of a CDN provider. They sit between the browser and the server, and they do fairly basic things. But with Cloudflare, they changed this up a little bit. And what Cloudflare actually allow you to do now, they have a feature called workers. And you can actually write JavaScript against a service workers API that you can deploy into their data centers, onto their servers inside the CDN. So Cloudflare's got 152 data centers around the world, and normally they just cache our JavaScript and cache our CSS or whatever. But now it's okay, you can write this JavaScript and deploy it into our data center, and we will run this code against your inbound requests. So what we did was, the very first trial of the service workers, we took the most simple piece of code that we could from our application servers, and we moved it into Cloudflare's data centers. And it was basically just super simple JSON validation. Is this a valid JSON payload? Because if it's not a valid JSON payload, we're not even interested in it. So that was the first thing that we moved into Cloudflare's edge. So instead of the browser sending the JSON over to us, and then us having to try and parse that and say, the JSON is literally not even validly formed, what happens now is we run that in a Cloudflare worker, and the Cloudflare worker will just return an error status code to the browser. So that doesn't even make a connection back to our origin servers. And this worked really well because we can get rid of 0.7%, I think it was from memory, 0.7% of the inbound requests because they don't even have a valid JSON payload. I was like, this is great. We literally don't even see those requests anymore, so the amount of load on our application servers goes down. Next thing was basic schema validation. All of these reporting mechanisms have an RFC and a JSON schema that the reports must conform to. So we moved our code from our application servers up to Cloudflare for that part. Are these reports, do they contain all of the keys that they have necessary according to the spec? If they don't, discard them. If they do, pass them through to our origin. And we're at the point now where we have pretty much most of our JSON pre-processing done in Cloudflare workers, and we've also actually moved the user entities that I mentioned, our application servers store. They're actually now cached in the Cloudflare worker as well. So the Cloudflare worker can do per user specific filtering on JSON payloads for an entity as well. The Cloudflare worker knows if a user exists or not. So it won't pass it through if it knows there's no user account associated. And what this allowed us to do was to free up all of the resources on our application servers to do things that we actually wanted to do. And then I kind of looked at this. This was going really well, and we managed to significantly reduce, again, the number of transactions that we were doing against Azure. So right now, it's about 3 months old, this data, but we were doing 0.006 transactions against Azure for every single report that comes in. But this month, we're actually on track to do 10.6 billion JSON payloads for our customers. So we are still doing quite a significant amount of transactions against Azure. And this is our infrastructure on kind of where we sit now. So this is representative of the current day. The browser sends it in. We've got most of our logic now in that Cloudflare worker, not running on our servers, but running on theirs, and also running really close to the user. We only have 2 data centers worldwide. Cloudflare has 152, and there's one literally just down the road in Sydney. So if you send us a JSON payload and it's not valid or it's going to get filtered, you can find out like 3 milliseconds down the road, rather than you'd probably hit our origin in San Francisco, which is like a few hundred milliseconds away. So it's a lot better performance as well. But the thing with this was, I looked at this and thought, well, we've kind of shifted like 2/3 of our functionality from our own application servers into the worker. Really, like, what's left here now? Like, why do we still have our application servers? Can we move our entire code into the Cloudflare worker? And it turns out we can. I've been testing this for quite a while with just my reports, and we can actually move the entire functionality into the worker. Now, the one thing that held me back was the Redis cache, because what I don't want is, the ultimate scenario, the end goal would be the worker just talks to Azure, and then we don't need anything, right? It could just process the report, place it into table storage. But we'd lose the benefit of the Redis cache, that if we get 10,000 of the same report, we can compress it into a single report, a single transaction, and we'd lose that economy. So I spoke to kind of friend / Twitter friend of mine called Kenton who works at Cloudflare on this. And there is actually a way that you can use a Cloudflare worker to buffer up requests inside it. I'm currently experimenting with this on my subdomain right now. So all of my reports are hitting this. The Cloudflare worker can simulate the buffer in our Redis cache. So any reports that come in from the browsers from my website, the worker will just stack them all up locally with a count. And then in 10 seconds' time, it will flush those out and pass them through to the origin. So we're kind of in this halfway house right now where once we finish testing this, and if the worker can handle this at the volumes that we need, which I'm fairly sure that it will be able to, we could actually get rid of literally all of our infrastructure. We wouldn't actually need any of this for report ingestion, because the ingestion servers are just doing filtering, schema validation, like custom filtering for users, things like that. The Redis cache is only there to deduplicate, and the consumer is only there to empty the Redis cache. So we could literally get rid of all of our infrastructure, and maybe we'll be able to do that this year. I'm not sure, but the ability for us to push our code out into the Cloudflare worker was a performance optimization at first, was for better filtering. But now as we play around with this, I'm actually becoming quite a big fan of what you can do with these things. So very soon, maybe next year, we might not actually have any of our own servers processing reports on the way in, which could be quite an interesting scenario. So that's kind of all of our infrastructure so far. What I want to do now, I'm running right on time, so I want to try and keep it that way. If you have any questions on this, I'll pick these up specifically at the end. I want to change the pace a little bit now and switch over to what it is that we're trying to do at a larger scale. So that's all of our infrastructure. That's how we got from hobby project into current, it's like 10.6 Troy this month, I think we're going to do, like 10.6 billion reports this month. Now, with that amount of data comes the scale problems that we've just talked about and that we've solved so far. And if you have any feedback on that, I'd love to hear it at the end, because I'm by no means suggesting that we're doing everything perfectly. But when you start to get that amount of data, there's other interesting things that you can do with it. And this is one thing that we've kind of come to find almost by accident. And maybe some of you here have large data projects in the organizations that you work for. We found that once you start to have this data in volume, you can do really cool things with it. So for me as a website, as the owner of my personal blog, I get my reports and I'm like, okay, I have a problem on this page and I'll go fix it. And for every other individual customer with their individual reports, they're interested in their individual problems and things that they need to solve. But we as a service, we can look down on this kind of ecosystem as a whole and say, are there many people out there seeing the same thing? Is this one customer got like a brand new problem that no one's seen before? Is this report a common scenario across thousands of websites or unique to them? And we can start to look at the data in aggregate. And there's two particular events that I want to talk about where we've actually used this data for purposes beyond kind of like the obvious fixing a website problem. Now, we get reports from basically every country in the world. Like if we go through and look at this, I'm pretty sure there's countries in there that I can't even recognize or spell. So we do have some pretty substantial coverage. To get those over 10.5 billion reports, they come from a lot of different browsers. Now, I mentioned earlier that we used to have spam filtering. And The problem with setting up a service like this is like, hey, here's an endpoint, and if you send it some JSON, it will do some really expensive processing and then database transactions. And like people see that and think, hey, this would be fun. What if I just send them loads of pointless JSON or whatever it is? So we've had spam detection for a long time because people like to do stupid stuff on the internet, including just sending you loads of garbage data if you run a service like this. Now, the spam filtering ones pick something up. And what we're trying to do is basically just look at our traffic on a larger scale and figure out if it's something that the user actually wants, if it's something we can throw away, if it's something that's no good. And we saw this one report coming in, and someone had actually flagged it to me at the time as well, which is why I looked at this more specifically. And they're like, look, we're getting this report coming in that's saying I have a script tag on my page. And it was like some crazy Russian domain. It was like just numbers and letters, .ru/a.js. And they were like, well, why are we getting this crazy Russian domain JavaScript on our page? Now, I looked at their report and I looked at our wider traffic volumes as well to see if anyone else was seeing this. And we actually found hundreds of different websites that were reporting the same issue. There was these hundreds and hundreds of websites that were all saying we've got this crazy Russian JavaScript file on our page. But no one could replicate that. And I went to a couple of the web pages when I was speaking to them. I was like, OK, well, I'm on the page. There's no crazy Russian JavaScript tag, yet here we have reports coming in saying crazy Russian JavaScript tag. And I was like, so is someone just sending these? Like, is someone just sat there crafting JSON payloads to make this look like a genuine problem? And I was like, well, not really. They have nothing to gain from that. Like, what would anyone spending the resources on this gain? So I actually got the JavaScript file that was linked. I beautified it, and I was scrolling through. And really, really sadly, I recognized a variable inside the JavaScript, and I more recognized the format of it because it was a Chromium extension ID that I saw inside the JavaScript. And I was like, hang on, that's, like, I recognize this. This looks familiar. Not the extension ID, just the format of it, that it was a Chromium extension ID. And that kind of quick-fired a series of thoughts in my head that was like, hang on a minute, this is an extension ID. Chromium extensions are installed on the client, and extensions can do things to the page, like inject JavaScript tags into the page. What if this isn't that you've actually got a JavaScript tag on your page on your website, but what if the user has an extension that's injecting this JavaScript tag into the page? Because then you would still have a JavaScript tag on your page. The browser would trip on the CSP and send the report, but if you went to the page and had a look, it wouldn't be there. And I was like, wait, these are not people reporting the fact that the website has a script tag on it. They're reporting that their copy of the web page has a script tag on it. And it turned out that it was a Chromium extension that had done this. There was a Chrome extension that had gone rogue. We were able to identify it with the extension ID. And it was literally just appending a piece of JavaScript to every page that that browser went to. And it just so happened that some of those websites were customers of ours. So I took all of this data. I was like, I really don't know what to do with this information. And I sent it to a friend at Google. And it's like a week or so later, some short time later, that Chrome extension vanished from the store, and they weren't able to talk to me any further about it. But what we'd realized was that we'd found a compromise on the client. So CSP and everyone's kind of thoughts of it, including mine, up until that moment in time, were about how do we detect like a compromise of the application? Normally, if you have a hostile script tag on your page, it's because cross-site scripting, a developer put it there, something kind of on the server side. But what we'd realized was this was a Chrome extension, and these things are super powerful. They can do anything that they want, basically, to the page. This particular one had gone rogue, and it decided to start injecting hostile script. And we detected that at a much higher level. And it's the kind of things that we are seeing more and more now. So that was kind of the first story. And on a very similar thread, we also had a similar thing happen again. Now, this particular one, it wasn't a Chrome extension. It was actually a piece of malware installed on an endpoint. And at this point, what we kind of realized was both of these had been picked up by like some spam filter thing, which is like a really super hacky thing that I just kind of built to save us some database transactions. I'm just going to rename it to our threat intelligence feed, because that sounds way cooler, and we can probably sell that for more money. But we had this other customer come to us, and it was a very similar story again. They came to us, and they were like, hey, you know, we've managed to fix like all of the problems on our website apart from this one. Our team cannot get to the bottom of why you keep telling us that we're getting this report. Now, the document URI here, the page, I've obviously masked some information. This was an intranet application at the company that got in touch. And they said, look, the only people that can get to this application are people literally in our office building or that are VPN'd in from home. So if someone's going to this application, they're literally a member of staff on our internal network. So this isn't like crazy stuff out on the internet. This is like 8,000 to 9,000 people that are on our corporate campus. I was like, right, okay, so someone's gone to a page on your web application, your internal intranet, they've triggered on a script source, and again, we're seeing like this crazy Russian domain. And it was another one of these things where I was like, what is it with .ru domains? And so I looked at this, and I had like the benefit of hindsight of the previous thing that we'd just been through. And I was like, well, look, we had this thing recently where it wasn't a compromise on your application. It was actually a compromise on the client. It was a hostile browser extension. And they were like, well, again, though, intranet site, like this is people within our corporate campus. This is not some crazy person on the internet with a virus-infected laptop. I'm like, well, that's what it says. That's what the evidence suggests. Because they kept going to this page on their application and saying, there's no script tag. I'm like, yes, but when the page gets to the client, if something on the client puts the script tag there, it does have a script tag. The CSP will trip, and it will send this report. So they were like, right, OK, so how do we figure out which client it is? I was like, well, this is kind of a problem because CSP is not meant to tell you that. We get the JSON payload, comes as a HTTP post, so all we see is their public IP. It's not like a per client thing, it's just their public one IP. And we do also get the user agent string of the browser, neither of which we store anyway, so we didn't actually have. But those are the only two things that theoretically we could have had anyway, and those aren't going to help you identify an internal endpoint. Now, we were trying to think of a way to fix this with a technical solution, which looks, and still to me, is basically impossible. But what someone in their organization was able to do was, based on the pages on the intranet site that this browser kept going to, they were able to guess what department in the company they worked in. And they literally just went to the department and had like a little stroll around and were asking people, looking at people. And they found an endpoint that had local admin privileges for a legacy application that this particular person needed to use. And it transpired that this endpoint had malware installed. So it had a piece of malware on there. It was like some crappy malvertising where it was trying to inject stuff into the pages that that user was going to. So again, it was like this kind of typical mindset of CSP in these reports is like, oh, you've got a script tag on the page. Go look at the server. The application's been compromised, so there's something there. But again, it wasn't. It was something on the client. This client had malware. The malware was injecting into the page. The CSP was blocking it, and then dispatching the report to us. So with all that in mind, I'm finishing right on time, and I did want to take some good Q&A in here. So thank you very much for everyone for coming. I will take questions now if there's anything at all that you want to ask, or even feedback, like I said earlier. If you've got any suggestions based on what I've shown you today, I'm more than happy to hear it. So thank you very much. So, questions? OK.
Moving all your stuff to Cloudflare, what's the costs associated with that compared to what you had? And I'm preempting your answer. If it's free for now, will it cost you more in the future?
So, oops, I can't remove that because my laptop will slide off. Let me just bring up the pricing for Cloudflare Workers. The answer is $5. Oh, sorry, yeah, repeat the question. So essentially, how much is Workers? What would it cost now? What would it cost later? So Cloudflare Workers is it $5 per 10 million? I'm going to bring it up right now, just so I don't get this wrong. And if I put this on to duplicate. So does that come up? There we go. So do they have the Workers pricing on here? I'm pretty sure it's $5 per 10 million, but I don't want to get that wrong. Cloudflare Workers pricing. Billing for Workers, that's probably it. OK, I'm pretty sure it's $5 per 10 million, but you can correct me on that later. Oh, is it there? Excellent. So there we go. So 50 cents per million after that as well. Yeah, so that's what I remembered. I just wanted to make sure I wasn't wrong. Cloudflare are supporting us right now. And it really depends on your workload as to whether or not, for us, in entirety, it would work out cheaper to be exclusively on Workers, which is where we're driving to. But it also depends what you do with them. If you're using a worker to do something that's not computationally expensive, then it might not be. So I guess it depends You're paying per execution, and how much it can save you per execution depends on what it was costing you. So if you're just doing like basic GET requests, then it's probably not, I would say, because we don't save money on our web application with this. We save it on the report ingestion because we do a lot of work there. So I guess it would really depend on what it is that you're doing with the worker as to whether or not it would directly save you any money. Does that answer the question? Awesome. Yes.
How CSP works with XSS if it's not external, it's online?
How does it, sorry, can you just elaborate a little bit, make sure I get that?
Right. Some XSS, which is line XSS.
Oh, gotcha. Okay, so that was more specifically, basically, how does CSP deal with XSS? In terms of CSP, when you enable this, two things happen. First of all script tags have to come from a whitelisted source, which was the evil.com thing that I explained. The other thing that I didn't get to was that all inline script is banned. Because if you have an inline script tag in the page, the browser does have no idea where that came from. So what you do is you take that script tag, the inline one, you externalize it and then load it from your own domain. And then the CSP can match on self. So that's how the browser knows that it definitely came from you. Now, that's kind of a nuclear option, no inline script allowed whatsoever. There are ways to whitelist inline scripts. You can hash them and include the hash in the CSP, which will allow specific inline scripts to run. Or you can also use something called a nonce, where you add a nonce attribute to the script tag, and any script tags with a matching nonce will execute. But those are quite, so it is possible, whichever way you want to do it. Those are slightly more in depth than I went on CSP today, but you can do whatever you need to do with CSP. There is a way to do it. I was just very light on the details today.
You want to put script inside CSS?
What about script inside?
Yeah, JavaScript inside CSS.
So again, it'd be back to hashing it. You could use the SHA-256 hash. I don't think you can nonce that. I've not experimented with using nonces there. I think your only option would be to hash it. You can actually just enable unsafe inline, as it's called, but I don't like talking about that because you should not do it, because it removes all the protection. So I would use the hash-based approach there. Questions or feedback? Yes? Go ahead.
One was on that denial service. Was the actual browser themselves, because they were sending out 64 requests, did the customer sort of notice a slowdown from their customers?
Okay, great question. So I mentioned during the DDoS that the customer's browser of our visitors could have been sending, can't spell my own name, would have been sending us like 60 odd whatever post requests. And would that have a performance impact for the client? Did I understand the question correctly? And the answer is no. The CSP reports are sent asynchronously by the browser, and they're also low priority. So Chrome has like cool features where it'll detect slow networks and use various fallback positions. And like most of those include sacrificing non-critical stuff like us, which is really good for us because we really can't have a negative impact on performance. I think this was the article. So yeah, we can see there's like one of them down here which had like 64 post requests for the site load. But no, we can't. We should never be in a position where we make your website go slower.
And the second one was, you've done all your validation up in Cloudflare. Do you get any feedback on those malformed JSON and stuff? Do you have an idea where those come from?
Okay, so do we basically do anything with the reports that we discard?
Yeah.
Historically, no. More recently, what we've started looking at is taking the ones that aren't quite spec compliant but are like still well-formed JSON and raising bugs with vendors. So I have countless bugs open in like Chrome, Safari. I don't think I have any in Edge, Firefox. So yeah, we are trying to improve the ecosystem in that way as well. Rather than just discard the invalid JSON, we have a massive downsample now where we let like 1 in 1,000 through just to see exactly why it was rejected. Most of the browser vendors are pretty good with this now and getting valid data to us. Sometimes it's obvious that people are just sending us absolute garbage as well. Why do people send JSON? I don't know, but they do. Yes? So the question there was, can an extension change the CSP header? And the answer is yes. An extension can just like completely nuke the CSP and remove it if it really wants to. That's the level of control that you give an extension when you install it into your browser. So theoretically, we were actually having a conversation with Troy just about this the other day. Because there's loads of valid extensions out there that do things like change the font or load a more readable font for people with visual difficulties. The CSP, number one, can't stop an extension because an extension is on the client and the client is king. Number two, the question then is like we're fighting with the extension. So CSP and the extension are like headbutting over who gets to run JavaScript or not. Extension developers really should either whitelist themselves in the CSP or disable the CSP to prevent the report being sent. Because we get a lot of reports like that where, hey, I've tried to add this like high visibility font and you've blocked it in CSP, here's your report. And it's like, well, we don't need to know that. But the extension developers, I think they probably just don't know about CSP right now. We don't have enough information and education out there about it. Another question? No? Shout? Oh, there.
You said CSP wasn't the only report, and you talked about HSTS and certificate transparency.
Yes.
Where do you configure how those reports, where those reports go?
So,
Like not at HTTP level, right?
no, they are all HTTP level. So if you want to configure any of these mechanisms, you configure all of them with a HTTP response header, which some people don't like because you're configuring things further down in the stack, like the TLS layer with a HTTP header. But for now, you do configure all of these with HTTP response headers. Any more? No, I think we're good. Thank you very much, then.